Alright, this video is about perceptual organization. So how do we actually perceive the things that we actually see and hear and touch and taste and smell? Well, this, your book actually has this after vision, but we could technically go and talk about this, about lots of the other senses. So, but we'll focus mostly on vision. So the first thing is this principle of Gestalt. And so Gestalt is this idea that we look at things and we try to perceive them as some sort of organized whole, rather than the individual pieces. So it's kind of that idea of the whole is greater than the sum of its parts. So, for example, I would usually go and show in class a desk, right? And when you're talking about a desk, you're looking at a desk and you're looking at it as a desk, but you're not seeing the individual pieces and angles and colors and shapes that make up that particular desk. You're seeing this organized whole, so you're seeing it as one big piece rather than the individual pieces that put it together. Another example is this kind of illusionary triangle here, and so you can see that because of the way that the circles are placed and these kind of V-like shapes here, we tend to perceive a triangle in here that does not have actual sides. However, if we were actually to close things up, you would stop seeing the actual triangle. This is the idea that we are trying to perceive some sort of organized whole. Now we can also talk about form perception. So how do we perceive form? Well, we do just tend to distinguish between the figure and the ground. And so figure and ground are going to be trying to pick out, for example, what is the important item, and then basically what is the background for everything else. So at the beginning of this unit, I showed a bunch of pictures. One of them being a picture of, it was kind of like a snowy covered rocky hillside, you might say. And in the beginning, a lot of people don't really see a whole lot, but then I tell you to look for horses, and all of a sudden you start to pick up on those horses, and the horses become the figure, and all the rocky hillside and the snow becomes the ground. That's what we mean by figure and ground. Now you can also pertain this to, for example, hearing. And so if you've ever been down a crowded hallway and somebody yells out your name, and all of a sudden, all the other voices become the ground, and the person who said your name becomes the figure. And so you're, looking around for the figure. Okay. Also very hard if, for example, you have a very common name, which gets yelled a lot. So that gets difficult. Form perception is also where we try and group similar stimuli together, and so we group by proximity, so what's similar in location to each other, similarity, continuity, connectedness, or closure. For example, this is looking at several of those. So proximity is showing that you're interpreting this as 3 groupings of 2 rather than 6 individual lines. Similarity, you're probably viewing this as columns of, a column of triangles, a column of circles, a column of triangles, rather than individual rows of triangle, circle, triangle, because we're trying to group together similar things. Continuity, you're probably viewing this as a wavy line that is interrupted by a horizontal line, rather than a whole bunch of half semicircles there that are right next to each other. Closure, you are obviously going to be closing the lines here, so you're probably seeing a triangle there. And then lastly, connectedness. Even though that there is some space in between here, you are probably seeing this as a series of lines and dots that are together, rather than, for example, 3 individual like barbell looking type things. Okay, this is how we group things together. So the other thing is that we can talk about is depth perception. So depth perception is this idea that we can see things basically in 3 dimensions, kind of 3D objects. And depth perception is a result of our eyes and how we actually perceive things. So the interesting thing is that there's been a lot of question about, when can we actually perceive depth? Okay? Can, for example, babies do it? Well, actually, there's been an experiment about that. So Gibson and Walk did this, what they call a visual cliff. And I think your book showed a picture of it. I'm not sure. I don't remember. But this is generally what it looks like. Basically, as you can tell, that there is this kind of checkerboard pattern here on the floor. And then they literally do have this kind of cliff here, right? And then they have the checkerboard pattern on the bottom. But across it, what they will do is they will go and put some sort of plexiglass, for example, that's kind of invisible. You can see through it. And then they will put on their babies that can crawl. Okay, so we're talking, 6-7-month-old babies and older that can crawl. And they will have them on, for example, this side of this platform, and the mother's on this side, and the mother's like, come on, come here, come crawl to mommy, right? And they're going to see, okay, well, does the baby actually come across this visual cliff? Obviously, it's very safe. They have the plexiglass there, but it makes it look like that there's a cliff that they're going to be going off from. And as you can see from this kid here, he's kind of very carefully putting his foot out there, trying to test the waters and trying to figure that out. What they found? Yeah. Babies actually do have depth perception. They could actually tell that this was a cliff that they might potentially fall off from. Inevitably, you have people that are like, well, if that's true, why the heck do I have to put up a baby gate at the top of the stairs? They can see that it's a cliff. Why do they still go there? Well, they're also very curious, and they don't necessarily understand what's going to happen if they go down the stairs. So yeah, you still need to put up a baby gate. But that's when depth is actually determined. Now, along with that, we can also talk about what we call binocular and monocular cues. These are going to be determined based off from if we're looking at things with 2 eyes or 1 eye. Okay, so 2 eyes are going to be binocular cues, and binocular cues help you judge the distance between 2 objects. So, for example, if you're looking looking down the road, you can see how far apart 2 cars are, right? Or you can look out and I can see how far apart 2 people are, okay? Because we're looking at them with our 2 eyes. So we can tell how far apart they are in a distance. But monocular cues will help us with relative size, texture gradient, relative motion, linear perspective, and interposition. So relative size is this idea that we will recognize that things that are closer to us are going to appear larger, and those things that are further away from us are going to appear smaller, which also relates to relative motion. As you're watching a car, for example, and I'm looking out the window, as the car comes closer to me, the car is generally getting bigger on my retina. That's telling me that the relative motion of the car is coming towards me versus a car that's going away from me is going to be relatively getting smaller as it goes off into the distance. Texture gradient, you oftentimes will see, especially if you're looking at, if you're an artist, or if you're looking at, for example, mountains, the ones that are closer to you are going to have a lot more texture to them. They're going to be a lot more finer detail, and the stuff in the distance is going to be kind of a lot more smooth and very general, right? Linear perspective, if you've ever drawn, linear perspective drawings, with the vanishing point, that's what we mean by linear perspective. And interposition, this idea that just because something is interrupting in front of you, maybe you have 2 people standing in front of another person, it doesn't look like your brain is interpreting that they're standing in front of and they're not interrupting the person behind them. Okay, so I do have a crash course to show you that of the size of this.
Every rose has its...
Oh, hold on.
Every rose has its thorn. Only the good die young, slow and steady, wins the race, and what you see is what you get. Except that in reality, several varieties of roses do not have thorns. Both the good and the bad on occasion tragically die young. Fast and steady beats slow and steady every time, and what you see is, well, our perception, or how we order the cacophonous chaos of our environment, is heavily influenced, biased even, by our expectations, experiences, moods, and even cultural norms. And we can be pretty good at fooling ourselves. In the last 2 lessons, we've learned how we see shapes and colors, hear sounds, and smell and taste the world's chemical concoctions. But our senses mean little without our brain's ability to organize and translate that data into meaningful perceptions. Without perception, your mother's face is just a combination of shapes. Without the ability to interpret scent, we couldn't differentiate the smell of toast from a grease fire. Our perception is the process that allows us to make meaning out of our senses and experience the world around us. It's what makes life understandable, but also it means that sometimes what you see is not actually what you get. So that was awesome, right? Upside down, I look like me. Right side up, I look like some kind of terrifying monster. Your brain isn't used to upside down faces, so it's basically just doing its best to put the pieces together. But it knows exactly what a right side up face should look like, and that is not it. Just one of thousands of examples proving that your brain does all the work of perception, and your eyes really are just feeding raw data. It's important data, but it isn't actually what we see. What we see is the realm of the mind, not the eye. What kind of bird do you see right now? A duck, right? But if I said, what kind of mammal do you see? A bunny probably would have popped out at you. Now, you should be seeing both of them popping back and forth. But likely your brain wants to perceive the image related to whichever cue you first heard, or whichever image is more familiar to you. By cueing mammal or bird, I influenced your expectations, and you saw what I wanted you to see. Cool. Your expectations are just one factor in your perceptual set, the psychological factors that determine how you perceive your environment. Sometimes seeing is believing, but perceptual set theory teaches us that believing is also seeing. Context is another factor in your perceptual set. If the duck bunny thing was pictured with Easter eggs all around it, you'd think bunny right away, which is kind of weird considering that of ducks and bunnies, one is actually much more likely to be near an egg. Not the bunny. And that's an example of how culture is also an important part of our perceptual set. As much as our perceptions are affected by context and expectations, they're also swayed by our emotions and motivations. People will say a hill is more steep if they're listening to emo by themselves than if they're listening to power pop and walking with a friend. Most of the time, your personal perceptual set leads you to reasonable conclusions, but sets can also be misleading or even harmful. They're the basis of tons of entertaining optical illusions. These two tables, for example, are the same size, but the positions of their legs make that impossible for you to believe until I lay them over each other. And while all the fooling of our visual perception can be fun, it also helps us understand how it works. Our minds are given a tremendous amount of information, especially through the eyes, and we need to make quick work of it. Turning marks on a paper into words, slobby lumps into the face of a friend, seeing depth, color, movement, and contrast, being able to pick out an object from all the other clutter around it seems so simple, but we've come to discover that it is quite complicated. So complicated that we have a name for it. Form perception. Take a neat little dynamic called the figure-ground relationship. It's how we organize and simplify whatever scene we're looking at into the main objects or figures, and the surroundings, or ground, that they stand out against. The classic faces or vases illusion is an example. Is it two faces against a white background, or a vase against a black background? If you look long enough, you'll see that the relationship between the object and its surroundings flip back and forth, continually reversing. Sometimes white is the figure and black is the ground. That figure-ground dynamic, though, is always there. The concept applies to non-visual fields as well. Say you're at a party holding up the wall and creeping on your crush across the room, trying to casually listen in on what they're saying. As the focus of your attention, that voice becomes the figure, while all the other voices jabbering about sports and beer pong and Sherlock and everything that doesn't have to do with that one beautiful person all becomes the ground. Now that your mind has distinguished figure from ground, it has to perceive that form as something meaningful. Like, for one, that large shape on the couch is a person, and further, that person isn't just any person, but the specific unique person of your dreams. One way our minds shuffle all of these stimuli into something coherent is by following rules of grouping, like organizing things by proximity, continuity, or closure. The rule of proximity, for instance, simply states that we like to group nearby figures together. So instead of seeing a random garble of partygoers, we tend to mentally connect people standing next to each other, like there's the hockey team over there, and the debate team over there, and then you got the band geeks, Why are all these people at the same party? We're also drawn to organize our world with attention to continuity, perceiving smooth, continuous patterns and often ignoring broken ones. We also like closure, and not just after a breakup. Visually, we want to fill in gaps, to create whole objects. So here, we see an illusory triangle breaking the completion of these circles on the left, but just add the little lines, close up the circles, and you stop seeing the triangle. Form perception is obviously crucial to making sense of the world, or, a moderately interesting party. But imagine trying to navigate the world without depth perception. As you gaze upon your one true love, the image hits your retina in 2 dimensions, yet somehow you're still able to see the full 3-dimensional gloriousness of their form. You can thank your depth perception for that. Depth perception is what helps us estimate an object's distance and full shape, in this case, a nice shape that is currently too far away from you. It is at least partially innate, even most babies have it. We're able to perceive depth by using both binocular and monocular visual cues. Binocular cues, as the name gives away, require the use of both eyes. Because your eyes are about 2.5 inches apart, your retinas receive ever so slightly different images. Camera 1, camera 2. So when you're looking with both your eyes, your brain compares the 2 images to help judge distance. The closer the object, the greater the difference between the 2 images, also known as the retinal disparity. Retinal disparity is pretty easy to see. You just hold your fingers up and then you look past them and suddenly you have 4 instead of 2 fingers. Because those left and right images vary only slightly, retinal disparity doesn't help much when it comes to judging far-off distances. For that, we look to monocular cues to help us determine the scale and distance of an object. These are things like relative size and height, linear perspective, texture gradient, and interposition. Relative size allows you to determine that your crush is not supporting a tiny newborn chihuahua on their shoulder, but rather there's a full-grown chihuahua behind them in the back of the room. In the absence of a chihuahua or like object, you can also judge distances using your linear perspective. If you've ever made a perspective drawing in art class, you'll remember that parallel lines appear to meet as they move into the distance, just like the tiled floor. The sharper the angle of convergence and the closer the lines together, the greater the distance will seem. And if you've ever looked out at a mountain range or a Bob Ross painting, you'll understand texture gradient as the cue that makes the first ridge appear all rocky and textured, but as your eye follows the ridges into the distance, they become less detailed. And finally, our interposition or overlap cue tells us when one object, like this oaf here, blocks our view of something else, your crush, we perceive it as being closer, and in this case, especially annoying. So all these perceptual concepts can be demonstrated with a fixed image, but of course, life involves a lot of movement. At least if you're doing it right. We use motion perception to infer speed and direction of a moving object, like your brain gauges motion based partly on the idea that shrinking objects are retreating and enlarging objects are approaching. The thing is, your brain is easily tricked when it comes to motion. For instance, large objects appear to move much more slowly than small ones going the same speed. And in addition to organizing things by form, depth, and motion, our perception of the world also requires consistency, or as psychologists call it, constancy. Perceptual constancy is what allows us to continue to recognize an object regardless of its distance, viewing angle, motion, or illumination, even as it might appear to change color, size, shape, and brightness depending on the conditions. Like, we know what a chihuahua looks like, whether it looks like this, or this. In the end, though, your perception isn't just about funky optical illusions, it's about how you understand the world and your place in it, both physically and psychologically. Your sensory organs pull in the world's raw data, which is disassembled into little bits of information, and then reassembled in your brain to form your own model of the world. It's like your senses are just collecting a bunch of Legos, and your brain can build and rebuild whatever it perceives. A party, your crush, a duck, or a chihuahua. In other words, your brain constructs your perceptions. And if you were correctly constructing your perceptions this lesson, you learned what forms your perceptual set, how form perception works, and the many visual cues that influence your depth perception. Thank you for watching, especially to all of our Subbable subscribers who make this whole channel possible. If you'd like to sponsor an episode of Crash Course Psychology, get a copy of one of our Rorschach prints, and even be animated into an upcoming episode, just go to subbable.com/crashcourse. This episode was written by Kathleen Yale, edited by Blake DiPestino and myself, and our consultant is Dr. Ranjit Bhagwat. Our director and editor is Nicholas Jenkins. The script supervisor is Michael Aranda, who is also our sound designer, and the graphics team is Thought Cafe.
All right, so you get the idea. Thank you, Crash Course. Let me know if you have any questions.